All right. Hi, everybody. And welcome to our webinar series, to the High Tunnel Berry Production webinar series. My name is Casey Athey, and I am the Specialty Crops Entomologist at the University of Illinois. And today we will be discussing controlling the environment in a high tunnel with Matt Kleinhenz. So Matt trained at the Ohio State University and UW-Madison as a crop physiologist and horticulturist. He partners with farmers and others to address current and emerging challenges and opportunities in vegetable production by capitalizing on managing environments near crops. For more than 2 decades, much of that effort has focused on enhancing the success of high tunnel users, regardless of their level of expertise. I want to mention that this webinar series is put on by several universities, seen here. University of Wisconsin, University of Minnesota, University of Illinois, and Iowa State University. Please, all attendees, do not unmute yourselves during the talk. If you have any questions throughout the presentation, please put them in the chat. We will then go through those at the end of the presentation. We will have survey questions at the end of the presentation, so we'll do that and then we'll get to our questions. I will also be putting some links in the chat for you throughout. One that will be they will be the links to the webinar when it will be on YouTube, so you'll be able to take a look at that after the presentation. And with that, I will go ahead and turn it over to Matt.
Okay, thank you so much. Thank you, Casey, and welcome to everybody. I hope things are going well for you, and I hope that the next hour or so that we spend together is very, very productive use of your time. And I'll just start by saying that if there's a topic or an aspect of the material that we cover during this webinar that you would like to follow up on, please do not hesitate to contact me. It would be a true treat to be able to work with you in that way. I'd also like to say that Josie and the team that Casey showed as responsible for this webinar series have done an amazing job. It's been a real treat to work with Josie and others to make it possible for me to join you today, and I'm very, very pleased with that opportunity. Humbled by that. So I do hope to provide you with some information that you can put to use right away, and perhaps some information you will kind of mull around and dwell on a bit and consider for your particular operation. So without further delay, I have been asked to discuss controlling the environment in a high tunnel. And I want to just say that I want to, that congratulations to the webinar series team for recognizing this as the important issue that I think it is. Clearly, there are many aspects of high tunnel production, regardless of the crops that are involved, that have their rightful attention. The entomology point of view, the pathology point of view, the nutrient management point of view, the crop selection, variety selection, all of the various aspects of our production systems that we have to pay close attention to are very, very important. I tend to think that managing the environment inside the high tunnel is also one of those that deserves some real attention. So kudos to the team for recognizing that. And again, thank you for letting me be part of the conversation. I'm a vegetable person, as you already know, so you might be wondering, how does this apply to berries? I hope to draw those parallels, okay? But at any time during the conversation, based on what you hear, that you'd like to challenge me on a certain aspect, or you have a question about it, as Casey said, please type your comments into the chat box, and we will do our best to address those live, today. And if we're unable to address them, then we can hopefully follow up in some way. But specific to the question of berries, there are some excellent, obviously, teams assembled around the question of how to produce berries in high tunnels. And here I'm just showing you a few pictures of representatives of that team and sites where they have done, their work. Okay, so there's a tremendous amount of information out there already on various aspects of high tunnel, berry production, whether that is, in systems like the one you're seeing here, in multi-bay high.
Matt,
Yes.
we can't see your slides.
Oh, goodness. That's problem. Let me try that again. Can you see the slide deck now?
Yes. Yeah.
Okay.
Yep.
So,
but we are seeing presenter view.
yeah, we're gonna split that, yeah, like we did last time, or just a few minutes ago. So, folks, I had those introductory comments, and to be quite honest, nothing in the slides was particularly salient, to those comments. You heard what I had to say, and the slides are simply there, to back up that narrative, if you will. So I'm going to hop right ahead to where I was when we discovered that you couldn't see my slides, and I apologize for that. So there's a fair amount of information available to you as berry growers, or on the overall topic of berry of production in high tunnels, whether it's a system like you're looking at, multi-bay tunnel, essentially a monoculture, or in this case, a polyculture of sorts, and on a smaller scale in a single bay high tunnel. There is information available to you, and if you have not taken advantage of that, I would encourage you to seek it out and explore it for all it's worth. As just to set the context, I've been working with 10 high tunnels at the research facility that I am part of for about 20 years now, from all aspects, covering the installation, the maintenance and repair, the testing, and the research of them, and then of course the associated extension. And of course, most of that has been geared around vegetable production, and so I'm going to do my best to link my experiences in that area with your experiences of what your potential future would hold as a berry producer. So spent a lot of time working with my own high tunnels, if you will, and the team that is here to help me with that. Also have spent a lot of time with many growers around the Northeast, Great Lakes, Midwest, even the Southeast and the Middle Atlantic states on this overall topic. And of course, I do try to stay up on the literature, if you will, what I can learn from colleagues in the research extension community who have reported on this very topic of environmental management. So it's a real treat to have them contribute to the knowledge base as well. And what all of that has taught me is that there's a tool, there's an opportunity for you to address your need most of the time that might require some innovation or improvising, but it does start with, I think, knowing the goal and how you will measure success in this area, and what your resources, what the resources are available to you. And that's going to be a theme as we get into the details of it. And why am I showing you a white and a black belt? I'm showing a white and a black belt. If you follow a little bit of this tradition, you are probably aware that in that circle, in that community, when one earns their black belt, of course, only after lots of experience, they're then considered to be an actual student of the form. Not that they haven't been a student all along and learning all along, but when they reach that level of proficiency, some would say now it's actually they're actually able to become a real student of the form. And I'm not saying that it's identical in this case, but what I am saying for sure is that even after this 20 years of working with tunnels in the way that I have, I still feel like I'm exploring new frontiers often. And for the first 4 years that I did manage the tunnels, about 45 years, I felt like I was working for them, not them for me. That may not be everyone's experience, but that was certainly mine as I learned how to manage the environments inside the tunnel. So we're going to focus on these factors. I've been encouraged to focus on the temperature, relative humidity, the light, and the wind, and the soil moisture as we go forward. I'd like to emphasize principles over exact methodology. Certainly, we will get into some of those, but time will certainly not allow us to get into the details of every how-to. That is also a function of the being true that you'll have to get to the specific how-tos for your farm, for your operation, a little bit through trial and error. But obviously, if you know the principles and have them firmly in hand, that process will be far faster and less painful. So high tunnel usually begins with staking a plot of land, driving some posts in the ground, putting the roof on, getting the structure in place, putting the top on using OSHA approved practices for sure. And then you have, at least in this case, a single bay high tunnel and an instant environment, if you will, in which one can produce any number of crops. This happens to be a tomato crop, but in your case, it's likely to be berries. So there's now a spot on the earth that is no longer open to the sky, open to all of the elements around it directly in the same way. And now it's your challenge to know how to manage it, whether it be the summertime, the fall time, or the winter time. And what you learn in that process, and probably what may have drawn you to it, is that high tunnels are really effective risk mitigation tools when they're managed properly. They are not effective risk mitigation tools when they're mismanaged or not managed properly, but they can be really effective risk mitigation tools when they're managed properly. And that's perhaps driving this incredible rise in high tunnel production that we're seeing throughout the United States, certainly in the Great Lakes and upper Midwest area. Whether it's a rural setting or urban setting, we have high tunnels on our landscape, and a large number of them through both private and public investment. So there's a lot of rightful enthusiasm around high tunnel production, including for berries, small fruits, and the other high value crops. So, but there is a problem, and that's the problem that we're going to be discussing today, which is high tunnels are not climate controlled greenhouses. But high tunnel growers have the same need to manage the environments in their tunnel that a greenhouse grower does and tries to capitalize on. So, that's essential to a high tunnel grower. And it's much like farming in a clear box without the aid of climate control systems. Yesterday, I was talking about the same topic, and I said it's pretty much like controlling the environment in your vehicle using only windows, manual windows at that. And that includes the one you can't reach in the back seat while you're driving, right? So this farming in a clear box without the benefit of climate control systems. So this feedback loop is immediately established. The weather combined with your management set the conditions very close to the crop. That crop's genetics and its particular physiology, as a combination with those new crop conditions, determine your cropping outcomes, and that cycle gets repeated and repeated. Now, so that's our learning curve, or that's our learning process. That's our feedback mechanism. And of course, what we want is the most profit possible from our management. We want this feedback loop to be working very much in our favor as consistently and as effectively as possible, because we do want to profit from our management. I'm in the process of preparing some resources that would be, I think, complementary to the webinar series that this excellent team has created. And in some of those articles, I've been, kind of asserting how important it is to understand and be able to manage the environments in and around a high tunnel. And I used this particular example. I'm not going to go into the details of here. It's not terribly critical. What I want you to see are the words at the left of the slide. The effects that occur as a function of your management are both acute, like in the immediate happening, immediate future, or they're chronic and so-called cumulative. I'm using that medical terminology of acute and chronic to indicate how severe and rapid the effects are versus how severe and rapid they are. It's slow but building, significant and disastrous, or saving the day in the immediate term. That's what's really at stake here. The data that you're looking at are just the temperatures in 5 different high tunnels relative to the outside temperature as a function of how I set the ventilation status. And if you scan those numbers or read that article, you'll see, and perhaps from experience, how quickly the conditions inside a high tunnel can change as a function of the outside conditions and the management, especially the ventilation status. Now, I tell the folks who work with perennial crops, my colleagues, that I think they have answered a higher calling. Everybody who works with an herbaceous annual gets a redo pretty often, okay? But those who work with woody perennials, especially, obviously the ones that flower and fruit and so on, they have a different beast in front of them, a whole set of challenges, issues, and opportunities that an herbaceous annual grower simply doesn't experience in a typical, cropping cycle, if you will. But all of them, if they're using a high tunnel, all of them have to contend with what's displayed here. These natural fluxes of energy, this is a bit of physics, but these natural fluxes of energy that are always occurring between the high tunnel and the environment that surrounds it are possibly one of the biggest challenges for any high tunnel grower to manage. Okay. This environment includes the soil beneath the tunnel, the air around the tunnel, and the sky above the tunnel. And as the cloud/sunlight conditions change, the wind speed and direction changes, the temperature changes, the moisture and the temperature of that water in the soil changes, so do the environments in the tunnel. And it's understanding these natural fluxes of energy and being able to mitigate or manage them as much as possible that really puts a high tunnel grower on a trajectory for success. Now, first and foremost, one really has to know, be aware of these natural fluxes of energy. So I would say that managing all these factors hinges on the factors here. The steps here, what is the goal of the goals? What type of high tunnels are you working with? How did you site them? What is their ventilation status at any one time? Do they have what kind of cover do they have? And how is the interior being managed? And we're just going to take these one at a time and get through to our endpoint. The goal will strongly influence, the goal will strongly influence the metrics that you use to determine if you're being successful. You can use a high tunnel for a lot of different reasons. Stop and examine what those reasons are and be comfortable with them. Are you just trying to protect the crop? Are you trying to extend the season? Trying to do all that? Are you trying to make more money in the length of the windows, get better markets, higher profit? Are you trying to adjust your farm situation to your farm situation? You want to diversify, any number of the attributes that are on this particular slide. Perhaps if the area is urbanizing around you, and you can capitalize on that market, but also deal with that reality. Perhaps you're addressing lifestyle or some other limitations. High tunnel production should make you more efficient, do more with less, if you will, but only if one is careful about it. Maybe you're looking for a greater stability or predictability, to reduce that risk, if you will, and the fluctuations that you're getting. There are all kinds of reasons that you would consider or possibly are considering to use why you're using a high tunnel. And amongst all of those is the need to recognize that the crops themselves or the high tunnels themselves can be damaged if the ventilation status is mismatched to the weather. Okay, now these are two really bad, extreme cases, but they do happen. And recognizing how much, what your goals are, including the availability of time and resources to manage the ventilation status, for example, which we will get to, ends up meaning that you might have to go back and forth. I apologize for the tomato example, but that's what I have most of in my files. This might mean one goes back and forth between wherever they are on or off the farm to the tunnel or tunnels to manage the ventilation status to account for the changing weather conditions. For me, this has been a significant experience, and I know for many growers that I've worked with, it's been the same. Either they have to do it, they have to pay someone to do it, or they have to cajole or convince somebody in their family to do it. Go back and forth to change one or more of the conditions, which we'll get to here in a bit. Well, just a little bit more than a week ago, I encountered this firsthand again. I was struggling with the reality in front of me. This was 2 Saturdays ago. Here, the wind speeds were really high, potentially damaging. The wind directions kept changing. The temperatures were fluctuating, 30 degrees over a 20-hour period. And that required me to go back and forth between where I was and the tunnels to accommodate those changes. And that was a typical reality for many growers. Now, on the other hand, I could have chosen, like some growers have to or choose to put the tunnels in a kind of a vanilla compromise situation and just live with the consequences. And for me personally, that's a choice between, what I see that as is a choice between two dislikable options. Either having to go back and forth to babysit the so-called babysit the tunnel, or accept what may ever happen by leaving it in one condition while the conditions around it change. Those are two unlikable options. This is what high tunnel growers tend to find themselves in more often than what might be obvious. So another factor is, how many and what type of high tunnels are you managing? Are they single bay structures like this one? That's freestanding rectangles on the landscape, each with two ends and two sides and a roof, or whatever their shape, whatever height, whatever width, what volume of airspace have you enclosed, and how have you done that? Meaning with what material, which we'll get to later. Or are they multi-bay structures? Are they designed like these two are to be 4 season, like they go, they're covered. You put that plastic on and you go 4 to 5 years before you remove it? Or are they 3 season structures and they're skinned and deskinned every year? And they're basically rainout shelters. They're just giant umbrellas. That's how many people use some tunnels. And I believe that is, I don't know it extremely well, but I believe that is fairly common within the berry, bramble, small fruit communities to use 3 season structures to essentially keep the rain off or any other precipitation and create, of course, these modified microenvironments, if you will. But those are all stationary. Do you plan or do you have a movable tunnel? Perhaps you want that covered temporarily in time, but you want to move, but the crop is stationary. So you want to not remove the structure, the skin like before, but you want to move the entire tunnel itself. And literally have it move across the landscape. I have one movable tunnel, and it is truly amazing. It has the options that it provides, but it is something that needs to be managed. The type of structure also includes, does it have ridge vents? They're very, very effective, but they can be expensive. So we have started with the goals, and then we've started with the number and type of high tunnels that one is managing. And then we'll go to the next factor, which is siting. How are those high tunnels put on the landscape? Now, I have a series of slides here that I'm going to go through very, very quickly in the interest of time. But again, we can follow up if you'd like. And they all have to do with the question, how I site the tunnel on my farm influence the environment inside of it? That's what these slides are about. And my ability to manage that environment inside the tunnel. So if it's not accessible to you, you're going to make fewer trips to the tunnel. You're going to be able to manage it less actively. Or if it's isolated from other inputs, oilings, and equipment, the same will be true there. It might be a little bit less efficient of an approach, right? Is the site well drained? If it's not well drained, the tunnel will sit wet for extended periods of time, which has its own problems, of course. Does it have full sun exposure? Does it allow air to move through it, but not too much air, just the right amount, if you will, protection from the most severe wind, but open access to enough wind for ventilation purposes. Wanting that free flow of air in the summer, protecting against the worst conditions of the winter, again, if that matters, depending on one's goals. So, the siting truly does matter to how you will be able to manage the environments inside the tunnel, including with regard to the airflow, with regard to, again, the situating of the single or multi-bay structures, and whether or not it's important to you to capture as much year-round sunlight as possible or not, because then that will affect the positioning of tunnels relative to other structures, perhaps another tunnel. It'll affect the amount of shade that you can tolerate, the drainage, the airflow, how you're going to remove snow, do your repair and maintenance, all these other jobs. And full well that structures around the tunnel and tunnels themselves shade or cause shade and can be impacted by shade. So we're asking the question here, here we're asking the question, what amount of sun exposure is most essential to you, given your goals? This is taken at my facility here. Notice the color of that tree, that maple tree, the shadow that it's casting. We are looking east. So the shadow of that tree is almost reaching the tunnel to the left, and it certainly covers the outdoor growing area that we have there. This is the same tunnel at the west end, looking at another tunnel just in front. Notice the shadow that tunnel is casting going forth. And that at certain times of the year, that tunnel this one is 80 feet long. They're all 80 feet long. That shadow at certain times of day can reach the tunnel that is 80 feet away. So knowing how to site the tunnel relative to your goals is very, very important as well. So that's a function, that will definitely influence the environment. And there are lots of tools to assist you in that process. I'm going to run, and I'm just giving snippets, examples of each. You know when the sun will rise and set. There are many uncertainties in farming, but you certainly know when the sun will rise and set. Basically, every day for the rest of your life. If you look at, for example, at the Naval Observatory databases and other databases which provide you with sunrise and sunset times for practically every location on the planet. So lots of things are unpredictable, but that's not one of them. So knowing when the sun will rise and set, how high the sun will reach, there are tools, all of which are free, available to you to help you determine the potential impact of siting the tunnel on your property, or the eventual impact of siting the tunnel on where it already is on that particular aspect of your operation. I always get asked, should I run it north-south or east-west? Do I want to, which one is best? I say the answer is depends on what your goals are, depends on what your wind situation is, depends on if you plan to have only one tunnel and how you would orient it and prevent yourself from having other ones if you want more. So the answer is not a pat answer like, oh, definitely northwest, north to south, or east to west. It is an integration of a number of factors. An integration of a number of factors is what's important there. So again, these tools are available to help you in the siting process. And you can see I'm spending a fair amount of time on this because once the tunnel is in place, if it is a stationary, you're not going to move it. And you will, from that point forward, be, if you will, dealing with or supported by the positioning or the siting that was chosen. I have some temperature data that I don't think is entirely, we don't have to study it, but I'm showing it to you in case you are unfamiliar with the conditions that can prevail. You look at the solar radiation line, and then you see the air temperature inside and air temperature outside the tunnel, and how the temperature tracks the solar radiation. This is something that's been long known. And in areas like the upper Midwest, which can be cold, and the upper Great Lakes, they can be cold, but they can be very sunny. And so we look at, we definitely look at the outside temperature, but we actually look more, in my case, we actually look more closely at the sunlight levels than we do the actual temperature. Now, again, I am deferring to you on the specifics of your berry crops and how they respond to a factor like growing degree days, how they respond to, there may be certain phenological issues or properties at work. So keeping track of the conditions inside the tunnel is very, very important because over certain quarters of the year, because as I said before, some of those effects may be acute or chronic, slow to build up or quick to build up. And in your case, if you're using a year-round structure, you may actually wish to ventilate it in the middle of winter so that it is not accumulating growing degree days in January and February. You may not want to break dormancy earlier if that is a factor. So keeping track of the conditions inside the tunnel is critical. And again, it will often track, all things being equal, it will often track the sunlight. And of course, is mediated by the outdoor temperature. So what is the condition, is the structure to be used year round, or is it to be used 3 seasons? As we alluded to before, covered 3 seasons is a very, very significant factor. Now, this is the same hot tunnel in 2 different seasons, middle of summer, middle of winter. And as you can appreciate, the side walls and end walls and their relative position, I call that the relative openness of the side walls and end walls. They are all components of the ventilation status. The ventilation status is another huge factor, component of the shaping of the environment inside the tunnel. So I'll spend a couple of minutes on it. As I said, it's the relative openness of the doors, side walls, and vents if they are present. Lots of different designs out there, as you know. Tunnels with and without vents, tunnels with and without sliding doors. Some are rolling doors, some are sliding, some are roll up, roll down. Lots of different designs. We can have 2 panels and sliding. We have lots of different options available to us. And all of those options will have their own potential, attributes, pros and cons with regard to your managing the environment. This is a single bay high tunnel that I have installed what is called a knee wall on. If we look carefully behind the plastic on the sidewall, you'll see about halfway up the sidewall, you'll see a metal row where it's behind there. That's just a single layer of wiggle wire track, single run of wiggle wire track. And what that allows me to do is attach plastic at that wiggle wire halfway up the sidewall and to the baseboard. And that when I want to ventilate from fall to spring, which I put in place in the fall and then I take off in the spring, when I want to ventilate during that time, I can do so higher above the soil line than would what otherwise be normal. Because in a roll up to open sidewall, the air will come in right over the baseboard, or if there is one, right onto the soil line. And I prefer that to not be true. Growing winter greens or springtime mixes and whatnot, I would rather ventilate from higher up and allow the air to mix before it settles to the ground. And it's a really inexpensive, very simple adjustment to the standard high tunnel design that we have used. It also very effectively grows weeds in the winter. But yeah, it's a very effective, inexpensive approach to managing, that aspect of the ventilation status. There are different sidewalls, of course. Some of them are roll up to close. This is an example of the, rolls down to open, rolls up to close. I actually wanted one of those. Was looking for them, but I never found one that I was completely satisfied with. Maybe my expectations are incorrect, but they would never seal at the top. And that was something adequately enough for me. That was something that I just couldn't get behind, if you will. But it is an intriguing option, to be quite honest, to roll the sides down to open instead of up. As you probably know, most of that ventilation status management is going to be on site and manual, whether that's an arm crank system like she's demonstrating here, or a hand crank system. This all has to be done. I don't care what the conditions are, at least in my case with the annuals. Whether it's a holiday, a personal day, whether it's evening time, morning time, it doesn't matter. The high tunnel needs to be managed, at least from my point of view, the high tunnel needs to be managed. I think most every high tunnel grower has stories to tell about when it was not managed well. I certainly have mine. I'll be glad to share them with you offline. But I've killed or nearly killed crops in the early days by not respecting that reality. A matter of hours or certainly a day can make all the difference. And you get into the process and you realize, you could harm yourself with that if you're not careful. Different mechanisms to change the sidewall position at the very least. You might be aware of Advancing Alternatives. This is a company in Pennsylvania that has recognized this issue and this possibility. They offer a climate control system that essentially, it has components and an algorithm And one can install these systems on their tunnel for many hundreds, if not thousands of dollars, and essentially transition at that point from being a high tunnel grower, doing everything on site manually, to being a greenhouse grower, setting it and forgetting it. I have one of these systems actually in one of my tunnels. I think it is amazing, but I've also experienced its definite weaknesses. And therefore, I do think that currently a climate control system of this sort is somewhat of a mismatch. I'm not here to disagree with advanced alternatives by any means. Like I said, I have this system and I like it a lot. But I do think for a vast majority of people, it is a mismatch between a technology for the need, if you will. I developed the system with this young gentleman. We just graduated from our computer science and engineering program. We have a system that's a do-it-yourself, very low cost, very straightforward system that allows people to control their sidewalls remotely using any sort of network connected handheld device. All the parts are available from Amazon or locally, and with just a little bit of programming and either a cell phone connection, a hotspot connection or Wi-Fi, one can have control of their sidewalls from anywhere on the planet, actually, that you have internet access. So we're really excited about that. We're putting that into larger scale testing, and I'd be happy to discuss that with you further going ahead. But the point here is to make data-driven decisions about the ventilation status. If you couple that with some other decision support resources that we're looking to, we're in the process of developing, you really have an opportunity. I think people will have an opportunity, and you can do some of this yourself as well. You'll really have an opportunity to make these data-driven decisions around what the conditions are in the tunnel, what they're forecasted to be outside the tunnel, what your crop needs are, what your personal situation is, and adjust the ventilation status accordingly. And very importantly, I don't have a picture here, but what this slide does not say, that I will say now, is that this system leaves the grower in control of the system. It rewards them for their knowledge. It rewards them for their experience. It rewards them for learning. It rewards them for being able to integrate factors far better than any current algorithm can, or at least an algorithm that most high tunnel growers can't afford. So it gives them that control. It allows them to operate, act on their motivation. Means an opportunity. So getting close to wrapping up, so we can get to the Q&A section here. The cover matters a lot. We've talked about the goals. We've talked about the type and design of the tunnel. We have talked about the siting of the high tunnel. We've talked a little bit about the ventilation status of the high tunnel. Now we're going to talk about the covering of the high tunnel. I'm separating this from the design and a number of days because I think it deserves its own discussion. Pay attention going forward. Pay attention to from the start. Pay attention to the types of covers that are available to you as a high tunnel grower. This particular product, and again, I'm not here to stump for or against any particular product. I have some experience with this solar ice material. It has in it a compound that actually creates shade inside the tunnel, if you will. It has still got the same amount of light penetration, but it's filtering some of that long wave radiation out. And as a result, until that compound breaks down in several years, the high tunnel can be, everything else being equal, the high tunnel can be 2 to 3, maybe 4 degrees cooler than a tunnel with standard film. Okay. So for those for whom that could be important or useful, that's something to take note of. That going forward, there may be some more films that will have similar types of properties in terms of helping with the management of the high tunnel. Pictured the environment inside the high tunnel. Not pictured here is a material that's a little bit more expensive, but it's pretty amazing. Perhaps you know of it. It is a plastic that you cannot see through, but lets enough light through for cropping, and very importantly, the light that comes through is reflected off of everything inside the tunnel, goes back to the ceiling, and is reflected back to the crop. So whereas in this case, I'm not saying solarized specifically, but your typical standard clear film lets a lot of light through, it hits something in the tunnel, it bounces back and it goes right back out to the universe. So if you actually measure the light levels at the level of the canopy of the crop, they can be higher in the tunnels covered with this film that you cannot see through. And it's stronger than standard poly, but of course it's also more expensive. So I'm just encouraging you to pay attention to the covering aspect of what's available to you as the film that your high tunnels are covered by. Clearly there's shade cloth and different weaves of shade cloth, different amounts of light that they exclude, therefore creating a cooling effect in the tunnel. You can use those to your advantage in different ways by covering part of the tunnel, covering it for certain periods of time, mixing or matching different levels of exclusion, 20, 30, 50, whatever percent, to create the type of environment that you're looking for, whatever that might be, and of course, you can cover certain tunnels, but not others, or certain parts of tunnels, but not others. So if you happen to be a multi-tunnel person, you can apply this material, use this material to your advantage in different situations that might be required based on the crop inside or your cropping goals. There's also a way, of course, there's the spray on lime or the liquid shade as you see here, which is a temporary material. It's sprayed on the tunnel. It stays for a while. It creates obviously its own shade. It's white instead of the black shade cloth material, like a woven material, that woven material. But the purpose is the same. And of course, what you're seeing here is somebody doing a pretty uniform coverage. This is not always necessary. One can put on a light coverage, if you will. And perhaps it's like dusting a cake with powdered sugar in some way, to use that analogy. Just, how much do you want to, and so you can meter it. You can buy this product where there's actually homemade versions as well. But again, they're designed to limit the amount of light coming into the tunnel if that is an issue. So getting to the interior management before we wrap up. And I know I've gone through this fairly quickly. You've seen a lot of slides, a lot of images, but I want to emphasize I was trying to cover the waterfront, if you will, the whole landscape as I see it of this particular topic. And I'll be glad to circle back with you both during the Q&A time or after today, if that would be useful to you. So we've talked about the goals that you have, the high tunnels that you have, both the design and the type. We've talked about the siting of the tunnels. We've certainly talked about the covering material. We talked about the ventilation status. And now we're going to talk about what's happening inside the tunnel. I don't have as many pictures or examples of this, but this is an area that I'm sure is fairly familiar to you, or an area that we can come up to speed on pretty quickly, pretty reliably, including through your own experimentation, if that's what's necessary. So here I'm talking specifically of how you would manage the interior of the tunnel. This is irrespective, well, for the purposes of discussion, this is irrespective of what those other factors are. What the ventilation status might be, what cover you may have on the tunnel, so on and so forth. These are options that are strictly limited to what you can do inside. Well, to move air through the tunnel is really, really important, especially in the warmest, most humid months. So many tunnels do not have access to electricity, plug-in power. This is perhaps where solar power comes in. Look very carefully. I would encourage you to look very carefully and very thoroughly at the options available to you to utilize solar panels on your farm to drive, for example, circulation fans. This is an area that is of great interest to me, and I'm trying to make inroads in that. And I will just mention that the Advancing Alternatives Control System that I described earlier, that was installed here in 2015. It is powered exclusively by one solar panel and one standard battery. We've replaced that battery one time in the 8 years. It's the original solar panel. and the control panel and the inflation fan of the double layer tunnel, the motors that drive the sidewalls, and the end wall vents are still working after this time with one solar panel. So do not let the lack of plug-in power dissuade you from considering options for bringing power to the tunnel, particularly in the form of solar, but it might also be wind, but certainly solar is an option. Because moving air around and through the tunnel and perhaps out of the tunnel can be very, very important for all the reasons that I'm sure you're familiar with, not only for the crop's physiology, the benefit of the crop's physiology, benefits to the crop's physiology, but also reduction in the amount of disease pressure that may occur and so forth. So we want circulated the air to be circulating through and around the tunnel. We also, and this is the last slide before we wrap up. We also want people to be aware, if they're not already using them, that they can create internal compartments inside the tunnel. Simple framing. I'm not talking about wood type of construction. I'm talking about post driven with wire strung between them, or wire hoops, or PVC, very, very simple PVC hoops, using the purlins of the high tunnel on the inside as a potential way to create an interior compartment. This is not unlike, if you will, a young child pulling together the chairs and the furniture and putting a sheet over it and making a little tent in the rooms inside the house, right, or the apartment. This is exactly the same approach, if you will, because the compartment inside that tunnel can have a different environment from the rest of the tunnel for whatever reason that you, as the expert plant person that you are, would want. Finally, I'll wrap up by saying, there are quite a few people who heat the air inside the tunnel. Fewer people heat the soil, but some do. And the economics of air and or soil heating, I think, are still being worked out, farm by farm, experience by experience. I have a fair amount of experience with soil heating from a vegetable production point of view. It does work. As you know, ground heating or soil heating can be more effective than air heating. The transfer of energy from the air to the soil is poor. The transfer of energy from the soil to the air is actually more efficient. But this is another option that you may want to consider, depending on your goals and your situation. So, you paid for the opportunity to create a specific set of conditions that should work for you and your crops by establishing at least one high tunnel, if not more. You have determined, or may determine, like, I need a high tunnel. I want a high tunnel. A high tunnel is right for my business. And with that decision and with that installation, you've now created a microenvironment. Then it becomes the process of testing and integrating the tactics that you're going to use to maintain the target conditions in the tunnel as consistently as possible. That means you need to know what they are and know what to do in order to achieve them. So I hope to have not gone too long after our introduction, and I apologize again for the brief delay about the slides, but we can turn to the Q&A now if everyone's ready.
All right, well, thank you very much. So I wanted to mention a couple things. First of all, if you look in the chat, I was attempting to put the links that Matt was talking about throughout the chat or throughout the presentation into the chat. So some of the things that he talked about, the different newsletter articles and some of that are all in there for you. If you would like to go and look at some of that. And then we will have some survey questions here that will pop up that we want the all attendees to please answer real quick. We'll have a couple of minutes for that. You can go ahead and start filling that out. And then once we do some of that, people can feel free to chime in with questions. There aren't actually any questions in the chat. So we'll have people just go ahead and you can ask questions, and please go ahead and fill out that poll for us.
I'm not sure if we have, of the group that's joined us today, what level of experience that they represent or they have, with high tunnel production. But it has often, from my own experience and I think talking with other people, it's often struck me how folks can underestimate what could be required to manage the environments inside a high tunnel to some level of satisfaction. Again, that's a floating metric, if you will. But it is, it can be very, very challenging in climates like ours, particularly in the very dynamic periods of the fall and spring. And then it's a matter of like how one approaches, thinks of their tunnel and what they want to get out of it. In my case, I frankly, when there's a summertime thunderstorm coming through, that's going to have, drop a lot of rain and maybe have high winds. I'm not particularly keen about leaving the tunnel open. So we tend to okay, the storm is about here. We drop it up, we close it up. The rain comes through, the sun comes through, but then, the sky's open and it's going to be 75 again outside really quickly. And that's going to be 105 in the tunnel. So we've got to be there to open it up. And someone said, well, why didn't you just leave it up, during the, well, that's half the point of having the tunnel. It's to not have the wind-blown rain and everything else that can come with it, not only from the crop's point of view, but the tunnel's point of view. Mm-hmm. So, yeah, anyway, I think there's individual learning curves with regard to managing the tunnel. And part of that begins with what they expect to be able to do, to gain from that, and what options they have to do it.
Yeah, I agree with that. I also think there's just a lot of things, so many things to think about when you're just starting out. I think this type of a topic is something that probably a lot of the things you talked about are things that I don't know if I was buying a tunnel today that I would think about some of those things as much as probably are necessary.
We have at the YouTube channel that I showed, there are a few very short, like 4 to 5 minute videos on selecting a tunnel and signing a tunnel that try to get right to the meat of the matter right away. Just very, very to help with the very basic questions that some might have at the outset.
Would you mind actually just typing that or a link to that? I didn't get that link put in the chat. Would you put that in the chat?
Let me just pull it up here, and then I will share.
Because I think that would be
you're seeing.
Oh,
are you
yeah,
seeing
yeah. Okay, excellent. Yeah, you just, yep. I will get at least most of that up in chat for us. That way they can have the link to that as well.
And I realize for some this can be, if you will, mysterious or can come across as daunting. Certainly, it's not meant to be daunting. It's just a respecting the physics of it all, the non-physics, right? And also encouraging people to find their own settling space. Like their own point to have. What's going to be their guiding principle as they work to determine how much they're going to manage this environment, and again respecting the differences between the perennial and non-annual crops that we all work with. That can be different. I have over time met quite a few berry growers who've been very satisfied with their tunnels about how it has helped their business. But I do think they have options and perhaps challenges that even like I say, the folks on the vegetable side don't. If only because if they do keep it warm in the winter, that could have different implications than keeping it cold.
Right? Yep. Yep, absolutely. Yeah, and I'll just welcome if, oh, here we go. Yeah, having somebody in the chat says having a high tunnel strong enough for the Great Plains windstorms is very important. And yeah, that's absolutely true.
I can't emphasize that enough, and I'm really glad it was put in the chat box. There are two people, and these, this team might know them. Rhoda Burrows at the South Dakota State University and Harleen Hatterman Valente at North Dakota State University. They have brought up the same topic. Ohio winds are Ohio winds, but North Dakota, South Dakota winds, Minnesota winds, Wisconsin winds can be different kinds of winds.
Mm-hmm.
So there are definitely steps to take to ensure that that soft polyfilm covered structure can make it through those types of winds. Yep. And of course snow as well. So definitely have your tunnel set up for the situation that it's in.
Yep, absolutely. Yep.
Yep.
All right. Well, seeing no other questions or comments, if anybody would like to, reach out, always feel free to do that and, look at some of the resources that we put in the chat. And thank you, Matt, for your presentation today. And I suppose we'll call it a day.
Yes. Have a good rest of the day, everyone. Thanks. Bye.